This conference will now be recorded.
Hello, everybody. Thanks for joining us. Jordan Girth from the National Weather Service Office of Observations here. Looks like we have a full room today. That's great. This is the Satellite Book Club Seminar Series, session number 12. You might recall from previous seminar series that we typically have meteorologists from our field offices presenting about new and innovative applications for GOES-R data, and other operational satellites. But today we're actually going to be talking about the future, and we have Pam Sullivan, the System Program Director from the GOES-R series program. They're on the webcam, and she's going to be talking to us about planning for NOAA's geostationary satellites in 2030 to 2050, and that's part of the GEO-XO program. So before we get started, I just want to give a few reminders. First, that the session is being recorded, and there'll be opportunity for Q&A after the presentation. And if you have questions, you can go ahead and submit them in the chat room, or we might have some opportunity for you to ask your question directly if it's particularly long. And we have that Q&A is going to be facilitated by Joe Senkowitz, the Ocean Applications Branch Chief at the Ocean Prediction Center. So we're happy to have Joe with us today. And if you don't have an opportunity to ask your question or provide your input about GEO-XO, there are going to be numerous opportunities in the future. So several engagements, the upcoming National Weather Association meeting. There'll be, I'm sure Pam will tell you other forums where you can provide your input as an operational meteorologist into how GEO-XO can enhance the services that the Weather Service provides. In general, we're always looking for future presenters. So if you're in a field office and have some ideas about satellite applications that are beneficial to you that might be applicable to the rest of the field, please contact us. Or if you're looking for training, there's training materials that can be created for you. Just let us know. We've got Brian Mata. He can take your questions regarding that. I'd like to thank our Tower S team, specifically Lee Byerly today for coordinating this, Office of the Chief Learning Officer, the GOES-R program at JPSS for supporting the Satellite Book Club. And without further ado, I'd like to introduce Pam, who oversees the development, acquisition, integration, installation, and acceptance of the major system elements for the GOES-R satellites. And she joined NOAA in May of 2018. And prior to that, she was at NASA, managing the GOES-R series flight project. And prior to NASA, she was an officer in the U.S. Air Force training as a space shuttle flight controller and supporting military space experiments using the shuttle. So great. Pam, thanks for being here today. Looking forward to your presentation.
All right, great. Thanks, Jordan. And thanks to everybody for letting a manager come talk to you. I hope I don't lower the standards for you too much. But I'm really excited about GEO-XO, and this is a great time to be talking to the folks that will eventually use the system and hear your thoughts about what you want in it. So let's see. You know, my slides aren't advancing here. Oh, they're advancing not on my command, but okay. Sorry about that. So to start with GEO-XO, though, of course, we need to start with GOES-R. And so this slide shows the timeline for GOES-R. You know, my friend Tim Schmidt will tell me there were a lot of smart scientists thinking about GOES-R before 1999, but from my perspective, the program didn't really start until somebody wrote down the first budget for it. So that was the first thing I got on the timeline, and then you can see we got into formulation for the instruments, eventually into implementation, got the spacecraft on contract, ground system on contract, did a whole bunch of reviews, and of course eventually launched GOES-R in 2016, and then S, of course, in 2018. We still have two more GOES-R satellites that we're working on. GOES-T, in fact, is getting ready to go into thermal vac testing in about a month. Still on schedule to launch that one in December of 21. And then GOES-U right now we're planning to launch in 24. And at the bottom you can see the bars represent the operating life that it's currently predicted for the GOES-R satellites. And so they'll be flying out into almost 2040 there. But when you run out of bars, you need new satellites. So that's where GEO-XO comes in. We're aiming for a 2032 launch for the first of the GEO-XO series. And that's because that's when we run out of the GOES-R spares. So GOES-T, GOES-U should be operating nominally in that time frame, but we're projecting that GOES-16 will demise, which means we need an on-orbit spare. So again, that's our target date for launching GEO-XO. It won't technically be planned to go into service until it's needed, which would be at the end of life of GOES-T. And I should say this background image, this is actually the very first flight image ever collected from GOES-R. So if you were in the control center on January 7th, 2017, this was the very first image that came down from ABI. Obviously wasn't made public. Obviously happened late at night, East Coast time, but that was the start of GOES-R. So GEO-XO, what is it? Why did we change the name? People have asked. And that's because we're considering more than just geostationary orbits. We're certainly going to have satellites in GEO, but we're also potentially including satellites that would go in a so-called tundra orbit. This is also a geosynchronous, but more of a Molniya shape, where it's got a very high apogee. And with two satellites in that orbit, you can have persistent coverage of polar regions. So that's something we are looking at. NOAA is also putting satellites operationally in the Lagrange point orbits, so the Sun-Earth L1 point, and the GEO-XO ground system at least will be providing services for that. So that's why the name got a little bit longer. So GEO-XO will include, as you would guess, the government satellites that we'll be launching. But we're also looking at some different models. We're looking at potentially having instruments or payloads, communication payloads that get hosted on either commercial or partner spacecraft. And we're also looking potentially at commercial services for data or for comm services. We're aiming to be operational over 2030, 2050. We're currently in a phase called pre-formulation, which means we've got a lot of studies underway, trying to assess what kind of instruments we want to fly and what constellations look like. We're also doing a lot of work on user needs assessments, and we're starting to write requirements for the system. Our approximate schedule shown below, we're trying to get to a mission concept review early 21. That's the point where we say this is what we think GEO-XO is. By 22, hope to be at system requirements review, where we've got requirements written down. And then the preliminary design review in 25, when we really know what we want to build and we're going off and building it. So I'll get into a little bit about the next decade of GEO. So kind of interesting to take a look at what the rest of the world is doing over the same time frame while we're building the GEO-XO system. In yellow there, you can see the Chinese Meteorological Agency has 5 of their GEO launches planned with a lot of new capability there. EUMETSAT, the green triangles, they're fielding their 3rd generation GEO satellite. These will be the first ones that are 3-axis stabilized for them. Their current system uses spinners right now. So this is a big upgrade planned over the European continent. In purple there, the Koreans have actually already launched GEOCOMPSAT-2B, which has 2 instruments that we're considering for GEO-XO. It has an atmospheric composition instrument as well as ocean color. So Himawari, the Japanese, they will actually be targeting launching their next system 28-29 timeframe. And then NASA is actually flying some experimental payloads that we're considering for GEO-XO as well. That includes TEMPO and GeoCarb. Those are atmospheric composition instruments, and then Glimmer is an ocean color instrument. So a lot of new capability will be going up globally over the next decade. So getting into what we're specifically looking at for GEO-XO, I'll make a little news here. There will be an imager in both East and West. We're looking at ABI quality or better. Some of the upgrades that we are looking at making to the imager are improving spatial resolution for the 3.9 micron channel, going from 2 kilometers to 1 kilometer to improve detection tracking of fires. We're also looking at improving resolution in the vis band, going down to maybe 300 or 250 meters to help with storm analysis. We're looking at adding spectral channels, a 0.9 micron that would help with low-level water vapor, and adding a green band so that we can stop faking those true color images that we produce. Lightning Mapper. We're also looking at next generation Lightning Mapper. We haven't decided. We may keep something similar to the GLM design, but we're also looking at potentially higher spatial resolution, maybe going down closer to 5 or 4 kilometers compared to the 8 or so that we're at right now. Also looking at a hyperspectral sounder. As you know, this is an instrument that NOAA's flown for decades on the LEO spacecraft. So we're doing some OSSEs right now to try to assess whether the benefit of building one of these instruments for GEO actually helps with numerical weather prediction. Got several studies actually ongoing looking at that right now. This would be an IR sounder with hundreds to thousands of channels. Another observation currently in LEO, the day-night band, like VIIRS has. This is something we're considering for GEO-XO as well. It probably wouldn't be quite as good as the VIIRS day-night band due to the higher distance makes the spatial a little bit harder, but anyway, something that would see in that spectral range is under consideration to help with nighttime clouds and smoke, things like that. So another type of instrument we're looking at would be atmospheric composition. Again, it might be like NASA's TEMPO or GeoCarb. Those are instruments. TEMPO in particular is kind of looking at pollution constituents. GeoCarb is more looking at carbon cycle. So this would be a UV vis spectrometer type of instrument that we're looking at. We're also looking at an ocean color instrument. Again, the NASA's Glimmer instrument may be a predecessor for us to consider, where we would obviously be monitoring ocean color with that to look for things like harmful alpha blooms or algae blooms, rather, or chlorophyll tracing, that kind of thing. Another instrument we're being looked at. If you're wondering how many there are, we'll stop after the next one. But this is microwave in GEO. Again, another LEO observations we've done for a long time, looking at how to do that in GEO. Spatial resolution is really tough from GEO, and this tends to be a really large instrument. So it's a technical challenge to have it in GEO, but it's currently in our trade space. So I mentioned the tundra orbit, and I'm showing a little bit of animation here. I really like the team in Wisconsin put together some nice tools to show you what that tundra orbit might look like. Of course, this is the view from one satellite. With 2 satellites, you get that constant view of the poles there. So, and we are talking about putting an imager in that orbit, or perhaps the atmospheric composition instrument as well. and looking at partnerships. The Canadians, for obvious reasons, are interested in putting a satellite in this orbit as well. All right, so this is a sample of the constellations we have under study. Each box is a sample constellation. The little cartoon, you can probably tell the blue curve is Earth, the numbers are the approximate longitude, and then each box is a spacecraft. So we're looking at everything from what we've got now, Imager and Lightning Mapper on the East Coast and West Coast, to adding a third or fourth satellite with some of the capabilities we just went over. The lighter colored yellowish boxes, those are considering missions that are hosted on commercial spacecraft. So those would be a single instrument on a commercial host, but obviously you can do more than one of those if you find more hosts. The darker orange boxes represent small satellites. So this is looking at if you're only carrying one instrument, how small can you make that spacecraft? Can you make it cheap enough to overcome the additional costs with launch and stuff like that. So those are disaggregated architectures is the term that we use for those. So those are in play. And then on the rightmost side, we're also looking at alternatives to building our own IR sounder. There is a company that's interested in selling us commercial IR sounding data as a service. Another alternative we're looking at, if you had enough of the LEO spacecraft, would there be enough coverage? Would there be enough of them flying over areas that you care about often enough so that you could get the kind of refresh rate that you would get from a GEO capability? So anyway, just to give you an idea of some of the stuff that's in discussion right now. And we're also looking at how do we get the data out to everybody. So the satellite, the GOES-R satellite, you probably know, has a whole bunch of communications relays on it. We relay the data collection system. We relay search and rescue. We provide the MWIN HRIT stream as well as the GOES rebroadcast. For GEO-XO in the future, the SARSAT will come off of our spacecraft. That's actually going onto the GPS constellation, so that's actually a better place for it. We think we're probably going to need to retain the data collection system. The data streams, though, we're really hoping to make use of the cloud capabilities in the future. Not exclusively the cloud. You can see there's other data distribution systems. For weather service, we still anticipate having a dedicated terrestrial stream for minimum possible latency. But we think a lot of users will want to use internet delivery, either terrestrial or through satellite internet or even through cell phone receipt to get probably what I would imagine would be mostly customizable data. So they, right now, if you get GRB, you get GRB. What I think we're going to be able to do in the future with cloud is make that customizable, and you can imagine all kinds of customizable situations. Somebody that only wants their local geographic area, maybe somebody that only cares about volcanic ash. But anyway, those delivery services, I think would be driven by a cloud-based solution with an internet storefront kind of thing. So anyway, that's what we're hoping to put in place for GEO-XO. And we do know there are folks that still need satellite delivery, so that will be part of the solution. Although I really think the majority of the users will be using the cloud service. So anyway, this is all in study, and this, as much as anything, we're interested in your feedback on the data delivery options. Which brings us to, yes, we would love to hear from you. Couple different forums, in addition to this one, of course. We've been holding user needs workshops. You can find out about them at the link that's there. We've got 2 more that are coming up later this month. on oceans and agriculture and fire use, or agriculture and land use, coming up later this month. Jordan mentioned we've also got a listening session planned at the National Weather Association meeting. NESDIS is also hosting a community meeting on NOAA satellites where we'll talk about GEO, LEO, and space weather plans. And of course, you can contact directly. Kevin Schraub, Jordan, and Dan Lindsay are all on the team of scientists that are helping us plan the next generation. So reach out to them, reach out to me. Now is exactly the right time for you to be giving us your feedback about what you want in the future. And I think that's back to Lee.
Yes. Hey, thank you so much, Pam. I'd like to just take this time to remind the audience that we're going to switch over and collect your feedback and your comments. And on that note, we have a record attendance today. We're up well into the low 100s, so pretty exciting there. I counted 111 at one point. If you'd like to leave any comments in the chat, please do. And if you'd like to pass along something verbally, just let us know in the chat as well, and we'll make sure you're unmuted. And so at this time, I'll pass it along to Joe, who's going to lead us in some discussion and Q&A.
Pam, thanks so much for this. And your earlier slide, well, one is I love the fact that the first image of from what became 16, but GEO-XO basically, even though it was you could see an ocean storm out in the North Pacific. I'm pleased to see that. But more importantly, seeing your timeline for GEO-XO and how soon we started is a reminder that we're on track now for the next series and how important it is to be part of the process as we move forward. So let me ask this question first. What do you think will be the most innovative things about GEO-XO?
Great question. We're looking at so much, and it's actually really exciting for even the engineers and even the program managers at this point, because almost everything is possible at this stage. As we move forward, we'll be racking up budgets, and not everything will be possible. But I'm of course really excited about bringing new capability, new observational capability. I'm pretty sure we're going to have, more capability than the GEO-XO series has. And so it's really interesting to me to hear from, Jordan and Dan and Kevin about, what the users are really wanting. So, we really like, that sense of mission and giving the users what they want. I don't know what those observations are going to be yet, whether it's a sounder or ocean color instrument, but going through that process is really exciting. But one thing that, the other thing we talked about, the data distribution, I really think that's going to be unique. With the cloud-enabled solutions that we can have in the future, I really think we're going to be not just giving better service to our current users, but greatly expanding the number of folks that are users. In our current system, not that many people outside of government agencies have real-time access to the data. But with the cloud solution in the future, I think we're going to be able to give almost everybody real-time access or near real-time access via the cloud. And so, so I think there's going to be a lot of creativity. As more people get access to the data, they'll be blending it with, different data sources, with, in map tools and creating new kinds of information and new kinds of applications. So I'm really excited actually about the data distribution options for the future. And also because you don't have to wait till we launch a satellite to get that. Some of these things that we're talking about, the cloud distribution, we're going to start piloting some of those things, I hope as early as 22, so that people can start to use them, get a feel for how they're going to work, give us feedback on how to make them better. So we'll start piloting some of that with GEO-XO series data, and to have, our user set completely ready by the time we get to GEO-XO.
So Pam, thank you very, very much. So we have one question from Matt Foster, and the question is, who engages with the NWS to be sure distribution and visualization systems are ready for this data, and at what point does that happen?
Right. Let's see. I think all along the way, I'm really looking to the science team that we've got formed to, help us advise on what the right ways are to do that. And they're focusing a lot right now on, the observations, the instruments that we want, because those are the earlier decisions. But that same team, Jordan, Kevin, Dan, and they've got a team of 20 plus folks that are working with them. They will also be in place to inform us on the data distribution, the visualization, the product piece of this as we go forward a little bit.
All right, thanks. So William Churchill, who's a forecaster at Key West, basically saying that this is really ambitious. Basically, it's a very exciting list of instrumentation. Which of the new GEO instruments will be most challenging to achieve?
Yeah, in terms of building them, the microwave sounder is probably the hardest thing. Nothing like it has ever been done from geostationary, and for it to be effective, it needs a really large antenna dish, and that it's hard on the instrument side. It's also hard to have a spacecraft that can carry a big dish that's moving, and so that makes it a pretty challenging system, basically, to build. Like I said, it's in our trade space, but it seems unlikely that one will make the cut. So that's probably the hardest one. But there's predecessors for, as you know, imager, lightning mapper, sounder now. Europe is putting a sounder on their system. The IR sounder is. And I showed you, Korea, NASA have plans for the atmospheric composition and the ocean color. So, those are within the realm of feasible. If we just those are our priorities.
So I'm gonna one more question from Mark Eakin. What do you expect the spatial resolution to be for the new GEO and for the XO instruments?
So for the imager, I think visible, we're studying going down to like 300 meter for the visible. The near IR is mostly going to stay, I think, around 1 kilometer. That is an upgrade in some cases. I mentioned the 3.9 micron channel. We hope to take from 2 kilometer down to 1 kilometer. The sounder spatial resolution we're studying, we're in the 5 to 10 kilometer realm. There's different concepts that do that differently. There's trade-offs with spatial resolution and how fast the instruments scan. So those are things we're looking at for that instrument. And then the lightning mapper spatial resolution, we're looking from the current 8-ish kilometer, maybe to half that, maybe as low as 4 kilometer.
Thanks, Pam. Okay, I'm going to ask, I think this will be, unless there's another question afterwards, but I'm going to ask this next one. We've talked a lot about, horizontal resolution. We've talked about bands. I think one of the biggest things that we've learned and are growing with is the temporal sampling with the GOES-R series. I think, we have minute up to 30-second imagery, depending on how the mesos are configured, much more frequent than we have radar scans. So we've flipped things on our application. Our use of satellite data has become tactical. We're not, the time delay in the system is minimal. We're actually seeing things in about as close to near real time as possible. What are the considerations for temporal sampling?
Right, there some of the instrument concepts we're looking at, some of the imager concepts we're looking at can improve that. There, some of the studies we're doing are, they're by specific companies and they're proprietary and they're in competition with each other. So, I can't say a whole lot, but there are, concepts that do more of a staring as opposed to scanning. And we are studying, I would say, optimizing the scan modes for the future. So I think we're trying, one thing I think we've heard from folks is that they really want, instead of, doing these 1 kilometer or 1,000 by 1,000 kilometer, where you have to pick which area is getting the 30-second or 1-minute updates, that the users would really like all of CONUS to have that capability. So we're looking at that. It's feasible. Like I said, it's trade-offs with other things, but it's in the trade space.
Great, thanks. Mark Eakin, as a kind of a follow-up, is do the resolutions apply to the XO as well as the other orbits?
Oh, well, tundra is interesting because the altitude of that spacecraft actually changes. So it goes up to 40 something. Well, yeah, I can't quote the numbers. I think it's about 1.7 times higher than GEO on the highest point. So as it comes across the northern hemisphere, it starts lower and then it gets higher. So you've actually got changing resolution. So when it's closer to Earth, obviously better. When it's further, absolutely, worse. But but we would, for the tundra, we would be flying the same instrument. So so if it's an ABI-like instrument, you'll be getting better than ABI quality for part of the orbit, but at its very highest peak, when it's actually over the poles, it would be, like I said, the factor of 1.7 less.
All right, thanks.
Yeah,
Brian Motter is asking, how will the private sector and small sat companies affect the plans for long lead, large government satellite program?
Dramatically in low Earth orbit, less so in GEO. Most of the kind of the new space companies and the CubeSats and small sats, that technology is really LEO based. It's making its way slowly to GEO. GEO is harder for radiation purposes and for 10-year lifetime. Most of that technology is not yet demonstrating those long life capabilities that we need in GEO. And the other thing, most of the LEO capability doesn't need a propulsion system the way that GEO does. So for GEO, we're mostly looking at the same kinds of technologies that we've been used in the past in GEO. We are looking, though, at different mission concepts. So the commercial hosting concept looks very promising. This is an idea where somebody's got a commercial communication satellite that's up there. They're broadcasting cable TV or whatever, or I should say satellite TV. But they may have room on their, nadir deck to put a camera, and we can get the data down. And because because they're making money commercially off of that spacecraft, it's shown, and NASA has been doing several missions like this, where for maybe a third of the cost of launching our own satellite, we could put an instrument on a commercial satellite. And so that's definitely in our trade space, and that's definitely one area that we're looking at that may allow us to be more capable at a cheaper price point.
Thank you. And it's an exciting time. So I think this will be the last question is, so how can a forecaster or an interested user or interested party get involved in defining what GEO-XO system will be?
And they all should get involved. So that's so the workshops, the page that's displaying right now, we really encourage you to come to those. And you can start with an email. Feel free to send it to me, or like I said, any of the scientists we've got on our team there. Let them know what your ideas are. What would be the most important upgrade for you to see to make your job better? Contact us directly. We're all in the NOAA directory, or you can hear a lot more about GEO-XO if you come to this community meeting on NOAA satellites. We'll be talking a little bit more about the constellations and the instruments. We'll be sharing the feedback that we've gotten from these user needs workshops. So there'll be, if I added it up, there might be 6 or 8 hours of discussion of the GEO system at that workshop. So you can learn more, and if that probably helps you think about more what would be advantageous to you. So by all means, come to that, or just reach out directly to us.
Pam, thanks. Actually, Brian Motta had a follow-up, basically, and this goes back to the microwave. And I was shaking my head as you were talking about the microwave. That the challenges, having a microwave in a geo orbit. I've often thought, that if you're willing to have an antenna that basically might actually lose a little bit of sunlight each day, but is it a seemingly insolvable problem, or a trade-off, or is there? Do you think there's any hope of getting one?
It's not impossible. So, it doesn't violate laws of physics. So that part's good, but it tends to be a more expensive instrument. And because it's a big mechanism it needs to scan, it kind of needs its own satellite. It's not a good neighbor for, something like an ABI or a GLM that needs a very stable platform. So, because it's on its own satellite, that makes it even more expensive. So, seems, if I had to guess, that probably won't make the value per cost cut, but don't know yet. So if, again, this is a thing where the user input may help us, make that decision. If a lot of people think that's really important, and that the value is higher than maybe we're thinking, then that helps justify what we would need to spend to get it.
Great, thanks. Actually, I'm looking at Jordan and Lee time-wise. I know we started a little bit later, but do you want to keep any more questions for Pam, or are we at the? I thought we were till 12:30, but.
Yeah, we've run a little long here. I don't know, Pam, what your schedule is, if you have more time, or if there's other questions to be asked, but certainly we can wrap it up.
I'm happy to answer questions if folks still have them. Up to you.
I'm looking at the audience to see in the chat, and so Brian Motta again. I think there could be some nanotechnology that would help enable microwave and geo. Is anyone looking at nanotechnologies?
Let's see. Probably not the way you mean. In the receivers, some of the guts of the instrument, those technologies are there, but they don't. Kind of the problem is we haven't yet got a design that makes the receiver significantly smaller.
Yeah. That's kind of what I figured was the limiting factor, at least with today's technology.
And I mean, we are studying things. There's things called sparse aperture, where you don't need a big dish, but you've got little receivers that go out on beams, if you will, that try to make up collect the spatial resolution with less signal. That is being studied, but again, it's compared to some of the other things that are on our plate, that's a more complicated, more expensive system.
Okay, thanks. Let me ask one about ocean color, because ocean color, sort of the application of ocean color is changed somewhat, in that now it's input into ocean models. And this is more of an advocacy question, is to there's the community. I mean, we certainly have a need. I mean, we get briefed on the Weather Service side every, I think it's Wednesdays now, on Lake Erie, and certainly when there's activity in the Gulf of Mexico with algal blooms. And I think with this, in fact, I'm hoping to do a talk in September in this session, just showing that the imagery capabilities with the higher resolution IR and temporal sampling over the ocean as to how the ocean really becomes alive when you have the combine the temporal sampling with the higher resolution. And what capabilities would an ocean color bring to NOAA, both from the data assimilation side, but then also in the application side?
Okay, I can't answer any science questions, but you know what? Maybe Jordan will follow up and can fill in a little bit. You know, what we're looking at in terms of instruments are, you know, something like what Korea just launched was, I think, an 11-channel, something like that.
Yeah.
You know, kind of capability that, you know, they have the advantage. They're really interested in Korea and Japan, you know, the oceans around there. So they have a smaller potential area of interest for them, but they're looking, I think, at kind of hourly updates in those 11 channels over the Korean area. So, so that would be one model for us. Again, it's you know, there would be trade-offs for us for temporal refresh versus how much area you want to cover. You know, is it primarily Great Lakes and Gulf of Mexico and, you know, East and West Coast? Or do you want to do open ocean, you know, those kinds of things?
Right. Yeah. Great. And Brian has one more. Will the U.S. be able to meet or exceed the existing Chinese IR sensor technologies and the European lightning mapping capabilities?
So that the Chinese, you know, right now the folks are getting the Chinese sounding data, and it's, you know, it's got some challenges. The Wisconsin team can tell you about some of the issues they're having there. But of course, China, I showed you, has 5 more launches planned, and they do plan upgrades over what they've got now. But I think they're aiming for about the same level that the Europeans will be launching. I think 24 is their sounder launch. And so that's in the trade space that we're looking at also, is to get into that kind of same range of performance that was actually recommended by the WMO. And then similarly for Lightning Mapper in our trade space to do something more like the Europeans, which instead of kind of a single telescope looking at the hemisphere, is got kind of the 4 telescopes. That is a concept that we're looking at.
All right, thanks so much, Pam. We're going to finish up there, but this has been great. I've learned a lot, and I think everyone that's participated, it's exciting to be at this stage and to look forward. But anyway, thank you again.
Great, thank you all.
Okay, thank you, Joe, so much for leading that discussion, and I appreciate everybody who's hanging on here. I know some of you have to get back to shift work and such. This was a really great audience and a really great presentation, Pam. Thank you. Every day that passes, I'm more excited about the future of GEO-XO, which is incredible because I was already at a high level of excitement when GOES-R launched. So it's been a great decade for our field users and incorporating satellite data. So thank you so much, Pam. And for everyone else, I'd encourage you to join us next week. We have a presentation from Emily Burnt at NASA Sport, and she's going to talk about the development and application of gridded NuCap soundings. So we're going to switch back over, talk a little bit about polar orbiting satellites with examples such as fire weather cyclogenesis and assessing the tropical cyclone environment. So with that, hope everybody's having a great summer, staying well, and I hope you'll join us again next week. Thanks, Pam. Thanks, Joe. Thanks, Lee, and take care.
Thanks, everyone.
Thanks, everyone.